Hello everyone, this is Professor Robert Solis and welcome to this video lesson. We're going to talk about the 4-bit register using 4 flip-flops. And so the way that this works out is like this. You can think of these guys as horses at the beginning of a race, and until the gate is open, which is what the clock is, the information will not transfer from D to Q. So all these horses are lining up, and instead of horses, these are bits. So D0 is the value that goes into here, D1 is the value that goes into here, so forth and so on. All these bits are lined up, and then when the clock is activated, all of those bits move to the output, which we are calling R0, R1, R2, and R3. Alright, so what I've done is I've created a circuit, again using the sciencedemos.org.uk, so that we can see what this thing looks like. And I want you to design this circuit. So you're going to put 4 D flip-flops, you're going to put 4 LEDs, and you're going to switch up, you're going to create all these switches. Now these switches are the D0, D1, D2, D3. So we can say that this is D0, D1, D2, D3, and then these are the appropriate outputs. This clock down here is going to be a push button. And that push button, when it's pressed down, as you can see, binary 1 is being fed into the clock, so it's creating a clock cycle. Alright, so what I'm going to do is I'm going to turn all of these guys off and then press, and then you'll notice that the zeros that are being fed into all of the D flip-flops have resulted in all of the LEDs being turned off. Now if I were to toggle every single one of these, you can see here that each of these is now binary 1, so if I were to press, now all of those move over to the LEDs and they get locked in place. Notice that when I turn these toggles on or off, it has absolutely no effect on the output, because the only way that you can change the output is to actually have a square wave on the rising edge, a clock cycle that moves the information from the D to the Q, or from the input to the output. Alright, so I can create various patterns. Like say for example, maybe I want this outer and this inner switch to be activated, so that means that this is going to be on and this LED is going to be on. Perhaps I want to change all of them so that it's just the inner two, right? So just these two, as you can see, are now going to be sent to the output. And so really what this is this is the foundation for a bus, or what is referred to as a bus inside of your CPU. So when you have information that you want to send to the bus, and the bus takes that information and gives it to something else, like maybe you're sending something from a keyboard to a word processor, or perhaps you're sending information from one part of your CPU to another part of the CPU. And it's like having a freeway that has, you can go in either north to south or south to north. How would you control that? Well, that's what the clock is for. The clock will determine when data can be moved from here to here, and allow you to transfer data based on these toggled inputs. Alright, so create this circuit, give it a shot yourself. You're going to use a bunch of D flip-flops and some LEDs, and then go from there. Alright, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.